Hello, everyone. Welcome to today's webinar, Launching a Cryptocurrency Exchange. My name is Diogo, and I'll be your moderator. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you are currently in a listen-only mode. You may submit questions throughout the session using the Q&A function in the lower right corner of your console. We will answer everyone's questions after the presentation. After today's webinar, you will receive an email with the recording. If you wish to contact us, please email us at team@singlestore.com. So let me introduce our speakers today. We have Dandy Suhubdi. He's the CEO and co-founder of Bitwire, and Dominic Ravita. He's the field CTO and VP of Product Marketing here at SingleStore. Welcome, Dandy and Dominic. You now have the floor.
Diego, thanks very much. I'm really excited about today's session. We've got a really interesting topic for you today. As Diego said, our guest today is Dandy Suhubdi, the co-founder and CEO for Bitwire. And he's going to tell you all about Bitwire, crypto, derivatives, and the system architecture here. Dandy's a really interesting and accomplished guy. He's a Fulbright scholar, and he studied at North Carolina State University, which happens to be my alma mater. Go Pack. He completed his master's there in mathematics and studied under Dr. Tao Peng, who specializes in stochastic control and financial mathematics. Dandy then went on to pursue his PhD with a famous deep learning expert, Dr. Yoshua Bengio at the University of Montreal, who founded the Element AI incubator, among other AI ventures. While Dandy was there, he co-authored several papers with Dr. Bengio and won an Amazon Alexa Prize for a chatbot that used novel deep reinforcement learning models. He's also a SingleStore ambassador, part of our inaugural class of ambassadors, and a key member of our developer community. So we are really appreciative for Dandy joining us from Jakarta today and sharing his story about launching a cryptocurrency exchange. We'll take questions at the end. And with that, Dandy, I'll hand the floor to you.
Hi, everyone. Thanks, Dominic, for the introduction. It's very nice of you. So, so today I'd like to explain to you our journey for the last 2 years for our team and what we've been building, right? So we'll start with some intro for you guys in the audience who might know or not know about cryptocurrencies or cryptocurrency derivatives. So what are crypto derivatives, right? So maybe you've tried out trading on your phone, and then you tried out a popular app in the United States called Robinhood, right? So you might have traded Tesla or Apple stocks, and then sometimes you've seen on Robinhood that there's options on Tesla or options on Apple. Recently, there's been a really famous a thing where there's like meme stocks, right? So there's option on meme stocks. So crypto is also another financial instrument. As you might or might not know, they fluctuate widely, right? So sometimes some people in the crypto ecosystem, for example, miners, need to hedge their bets to make sure at a certain date they have a certain revenue. For example, the miners, right? So miners, they get revenues from mining. And then, for example, they get 1 or 2 bitcoins for every block, right? Right now the block reward is I think 32 or 16. Correct me if I'm wrong. The crypto audience here might know more. So for a derivative is just a financial contract. So a miner enters into a financial contract that guarantees, for example, that he or she can sell 1 Bitcoin at, for example, 60K USD or USDC on a December 31st delivery. most markets like Coinbase, Crack, and Robinhood Crypto are mostly spot markets. So you buy and sell right now. But for derivatives, you enter into a contract to buy something in the future at a pre-designated price. Now, what Bitwire's team has been building for the last 2 years is a crypto derivatives exchange. So we're founded in 2019, and then we're going to launch worldwide in a few months, hopefully this fall. We are able to process 1 million orders per second at launch. And so you might ask, what can you trade on Bitwire later? So at launch, there's a couple of spot pairs. There's going to be Bitcoin USD stablecoin pairs, and then Ethereum USD stablecoin pairs. And after launch, later we add more popular crypto pairs. For example, Zcash, Monero, Tezos, and Cosmos, TS, and Solana, of course. These are mostly modified Turing complete blockchains. So you might or might not know from your friends those cryptos that are pretty popular right now. And then also the most important part is derivatives, right? So we're going to offer crypto USD monthly futures, monthly options, and then also perpetual swaps. Later, hopefully, we're going to have a premier line for crypto interest rate derivatives that the counterpart that's only traded in the traditional finance part is done by the Chicago Mercantile Exchange. So we develop the trading application from front to back, right? So you can see we developed Bitwire, and then you can see it on the left compared to FTX, another popular cryptocurrency exchange. So what you can see here is what we built is not only a cool front end. So we also built a very fast back end that compensates with the front end that you can see. So today I'd like to explain the nuts and bolts to you, and then our journey for the last few years of how to build a crypto exchange from the ground up, right? So there's a couple of problems that we see when our team saw multiple crypto exchanges. The first one that we really took notice is that most crypto exchanges are done via a rapid bootstrap and delivery without the design for scalability. So there's a famous story that 3 founders in Hong Kong started a crypto exchange and then worked their code up from Starbucks, for example. But they had like a single database, and then it wasn't really designed for scale. So some of you might like ask, so why is scale important? Well, in my opinion, or not just me, maybe the whole team, that if central bank digital currency comes in, or what we call in the crypto space is Fedcoin, you can imagine every single person living out there, the 6 billion at least on the planet that we can count, might need to be able to buy and sell crypto on centralized exchanges or even decentralized exchanges. Now, none of the existing crypto exchange design could cope with that scale. Maybe the ones that have that kind of scale are NASDAQ, NYSE, and CME, and those are centralized exchanges with have old old stacks and they don't quite use the new stacks that we have right now. As you can see, we've seen multiple outages. There's an unnamed crypto exchange in the US that even though every single time there's a price hike or a price drop, more than 10%, for example, there's outages, right? And then we try our best to design our exchange from scratch to have a minimum outage. So you might ask yourself, okay, so how do we do things differently, right? So we do a couple of design trade-offs, right? So there's 4 main trade-offs that we've done. For other exchanges, mostly they're they are monolithic and they have a single database. So for that unnamed crypto exchange, they use, for example, a singular database, two of them, one that is based outside of the US and one that is based inside of the US. I won't name names, but like both of them use a singular monolithic database. It's not wrong, but like it's against the scalability principle. So we tried from scratch to do it in microservices. The second part is single thread versus multi-threaded. So most exchanges think that, okay, since it's a single thread, you can use multiple. So since it's a single database, you could use multiple threads to achieve like a higher throughput. In our case, we designed our system so that it's synchronous, but it's single threaded. So there's multiple partitions with messages queues. So each single thread consumes a message in parallel. So the next one is how we design our matching engine. We'll come back to in detail later, but most exchanges do their matching algorithm inside the database. So for us, we use all in-memory data structures with event sourcing. We achieve like north of 1 million orders per second on this matching algorithm. And then the next part is something that's unconventional, which is cloud versus bare metal. So most other exchanges use cloud. For us, we use bare metal for our deployment. I want to show everyone here. So this is the example of our racks. So we have 3 racks now, and then counting. We just bought the 4th and 5th rack. And that's me with the servers. We'll set them up probably this month. So what do you care about outages, right? So outages would cause, for example, there has been a story about a Nordic trader that traded gas contracts that caused almost a clearinghouse to go bankrupt, and that risk checking by the clearinghouse wasn't done properly. So that's one. Last year, Tokyo Stock Exchange was paralyzed by a hardware glitch. So that outage was detrimental to most of the Tokyo or like Japanese financial community. And also in 2000, the early days of internet, I guess there's a software glitch that was forcing NASA to shut down for 11 minutes. So there's indication of these outages, right? So the first indication that's obvious is loss of trading volumes. Like for us as an exchange, we earn trading fees based on trading volume. So a percentage or a fixed fee based on trading volumes. So if like you're stopping for 11 minutes, that causes like you to lose not only like trading fees, but also confidence from the traders. The second part is lawsuits, because the traders might trade on sale quotes, and the problem with that is the quotes that they see are not quite the quotes that are happening at the moment inside the matching engine, and that's problematic. That could cause number 3, which is cascading liquidation. So liquidations happen when you're like over leveraged, and then, for example, you borrow money to buy crypto. I don't recommend you to do that, but like some professional traders do that to amplify their gains. But you could also get your loss amplified. So in that, when you have that much of risk staked on an exchange, you don't want the exchange to have an outage. And the traders do have the right to sue the exchange, and then you get potential losses. And then after cascading liquidations, the exchange itself could be bankrupt if the clear positions are not marked to market. There's this recently new development in crypto where you could do auto deleveraging, but that's another different topic. but mark-to-market, real-time mark-to-market is really important in the derivative space. So let's here I'd want to like be very open to you about our architecture right now, flow diagram. So we have three kind of gateways. We have the REST gateways, WebSockets, and then in progress of building the fixed gateways for you trading professionals in the audience. We try our best to have Bitwise design to be circular, right? So basically single-thread non-blocking. So if an order gets sent to the REST API gateways, that gets sent to the order management system or also the order management feed engine. So that so for example, if you send a buy order for 1 Bitcoin, for right now the Bitcoin price is correct me if I'm wrong, 40,000. Hopefully going to go up, right? But that order would be timestamped and said like, okay, this is just a new order. That's what the order management system does. And then it is sent to the risk engine and says, okay, hey, this trader just sent like an order to buy 1 Bitcoin at $40,000. Does the person have enough USD to cover his purchase? And then the risk engine says, okay, so he does. Now the balance gets locked, and then it's sent to the matching engine. The matching engine then like matches the order with current orders that are inside the matching engine, and then sends back the update to order management system. Ideally, you have a different state for order management system and risk engine. So in our system, the order management system has a single table called the order table, and then the risk engine has different tables, but the main table is the account balance table, and also the derivatives account balance table. So both the order management system and the risk engine have their own states, right? And then post-matching engine, the data is sent to the WebSocket API gateways and then sent back to the trader, and then that goes in an infinite loop. Now, what I want to show you here is that from my experience using SingleStore, that you can still have the microservice principles and not violate it by having singular states, even though you're connecting to a single store cluster with 4 nodes. So the master aggregator, child aggregator, leaf 1 and leaf 2. Here's the explanation on simultaneous reads and writes on Bitwise architecture. For example, let's go deep down inside the order management system. So we, other than the matching engine, we put every engine inside Kubernetes. So there's fault tolerance and resiliency. So if we delete one pod, for example, if there's currently we have 7 pods, or you can call it replicas. If you delete one, like automatically Kubernetes would spawn back the 7th one, right? So here SingleStore is able to still have really good latency, even though there's like multiple pods and parallel reads and parallel writes on top of Kubernetes, Proxmox, and bare metal. So previously, what we did at the beginning is that we used Redis, and then okay, so you might ask, okay, so why did we use Redis at the beginning? Most of my trading friends from New York suggested that, okay, you should use just an in-memory data structure, right? And then the naive me, at the beginning of the beginning of the journey of the team, we chose Redis. And then after like 6 months, we dropped it, and we chose to move to SingleStore because it's also in memory, but it's just much more better. So I'll explain why. So on our first 6 months of using Redis, we realized that, okay, Redis is single thread. It uses single threaded. There's this problem where there's we have dirty reads, and then there's race conditions when you pull out read, when we write and read data. Sometimes when you write and read data, there's you need to implement locks, and these locks really slow things down. And then when you implement Redis, like as a state mechanism for example, the gateways eventually time out if there's the engines are trying to write it, and then the gateways are trying to pull it out. So there's a timeout. Because of the consistency model, we always get the updated data. So for example, account balance states, right? So when you want to do risk checking, there's an in-flight clearing mechanism that comes from the clearing engine, and then okay, so the database locks, and then suddenly there's a sell or a buy order, right? So the risk checking couldn't consistently define, oh, should the person gets sent to the matching engine, or like should it like not be sent to the matching engine because like the risk checking isn't done properly. So those state dirty reads are really, really problematic. It is optimized for fast writes, but not for simultaneous reads and writes. And then in a trading application, that really is problematic. For example, order updates. So when the orders get sent from the matching engine back to the order management system, and then it's okay, timestamp, like okay, so it's updated, it's filled, right? So for example, if there's another read that's happening at the same time before, it's going to be a problem when you use Redis. After all of this, we realized that Redis lacks durability and resiliency in the face of failure. So there's a couple of links that you can say that you can look at. We put that in the presentation. But it's really better if you use Redis as a cache layer instead of like a persistent layer. So after 6 months, we were just like, okay, well, let's move to SingleStore. We didn't get any dirty reads. It really scales for simultaneous reads and writes. The data, so there's tiered storage, right? So the data that is needed is stored in RAM or RAM first, then in persistent memory, non-volatile memory. Then the ones that aren't accessed the most are saved inside SSD and object storage. So for example, in our case, we used order states, right? So order states that are very, very recent. So happen like, for example, like since we nanosecond timestamp, for example, it happened in the last second, right? So it's saved in memory, and then it's really, really fast. And even though we have all these properties, it is still durable. It's really good for persistency. We'll show that later too. So one experiment that we did that's really interesting is that we tried to test the resiliency, or some of you guys may have known about Chaos Monkey. So we tried deleting multiple pods when the trading was happening live. It went good. So we tried one more thing. We tried to, since we have the enterprise license or the premium license right now, we have high availability nodes, and then we tried deleting one leaf node, and then we would look at if it impacts the trading system. But we tried this in live production, right? So we did, if you remember the previous graph, or we deleted one leaf node, and then not like so far it acted like nothing, there was no problem with the order management system whatsoever, and then we retrieved like order updates as normal. So this was something that we were really, really happy about as a trading application or trading platform. Talking, so that's pre-matching, right? Now the matching process itself, we did a new design. Previously, it was like synchronous, and we did a mistake there, but we finally figured it out. And then a big thanks to Songking and Eric for the help with this. So Songking wrote uh, a V2 of our matching engine, and then we're able to get consumer throughput of 1 million orders per second, matching throughput of 6 million orders per second, and then they're producing throughput of like 1 million orders per second with multiple. So we're using a concurrency queue or ring buffer for the producer. We use multiple reads, and that allows us to level out the consumer and the producer of the events. So why am I talking about the matching engine, right? So the data that's produced post matching engine is really there's a lot of data that's produced from there. So there's in our after our matching process, is like 4 events that are generated and sent to Red Panda topics, order events, snapshot events, and trade events. So the order events are the ones that are needed to clear the trades. So the state changes is processed and then saved inside a state. For example, the order state, right? It's saved inside like SingleStore that is used later for the REST APIs to be sent to the gateways. So traders could see real-time updates, not just for REST, but also for WebSockets. If you subscribe to our WebSockets, you could get a real-time update on our matching engine data or matching engine state. We also, a little bit on this, we wrote a really cool C++ program. It's called Megaphone. Please try it out. We'd love to get your input on it. But that data also the data for the WebSocket private gateways, we use Rust, and for the WebSocket private gateways, we connect to SingleStore via SQLX. If you're like a Rust, professional Rust developer, you might check it out for asynchronous Rust read and writes. So the time series data is saved inside Column Store for further analysis. For example, for regulatory purposes, like fraud detection, wash trading detection. One thing we're really proud about in Bitwire, we don't allow self-match. So we have a self-match prevention algorithm. We also do insider trading analysis, and since there's a couple of events that has been lately been showing up in the newspapers, and then various real-time market statistics. So we're so the choice of using SingleStore is pretty obvious because, first of all, we're not like VC funded, right? So me and the whole team, we grew. We hired our 12th or 13th. Not including contractors. So including contractors is around 17 people in the team right now. And then, yeah, we bootstrapped it from the last 2 years, and we're really happy. Right now, we're running our own hardware. We're self-hosting everything. And then we're also self-hosting SingleStore on top of 4 VMs on top of the bare metal. The enterprise license allows us to scale the trading engine to 1 million orders per second or 1 microsecond latency on average compared to other crypto exchanges, which are at around like 18 milliseconds round trip time. So we had a blog post in detail about this. We'll show it to you. So yeah, I guess you know, thank you for attending this webinar. And then for the crypto enthusiasts in the audience, we'd love to, if you want to subscribe to our launch, go to our link, bit.ly, Bitwire. So thank you.
Dindy, that was fabulous. So much to dig into there. A lot of information, a great education on cryptocurrencies, derivatives, building an exchange, also the technology. We're going to open up to Q&A for the audience in a moment, but I've got a few questions I thought I'd ask you here. You know, you wrote an article about this a while back that you shared on the SingleStore blog, and you were talking about the experience of migrating from Redis to SingleStore. You had something like 100 microservices. Tell us a little bit about what it was like to migrate from Redis to SingleStore for that many microservices.
It was interesting at the start. We didn't have any major challenge moving to SingleStore because the developer experience was really good. We got gone through a lot of SQL documentations. Now we're familiar with SQL, but not in detail, right? But after seeing like SingleStore's documentation, it's it's pretty much changing. Changing the host port to SingleStore. Mostly the syntactic changes were writing SQL, and our team we're very happy to have some really cool devs on the team to write it. And we didn't miss the locks, that's for sure.
Yes. And how long did it take to migrate that many services?
It took less than 2 months to for doing all of that. Yeah, I remember me and another engineer called Augie at the beginning were just rushing into writing all the code. It was including all the tests, right? The unit tests, and we did all the migration in 2 months. Yeah, that was really nice.
Well, and in your you've shared sort of the flow diagram of the architecture, and you're dealing with a lot of fast-moving, fast-changing data. You know, how are you moving data around, right? I believe you're using a kind of Kafka-like technology to move data across the system. Tell us a little bit about the other technologies in the system.
So we used a Kafka-compatible API that's written in C++ called Red Panda. So shout out to the vectorized Red Panda team, Alex Gallego, who has been really nice to us, to be helping us from day one, I guess, to help us put Red Panda into development and production. So previously so if you see in the slides, we use event sourcing for the matching engine. So there's this cool part where even though we nuked the matching engine, we could replay the matching engine from start, right? So we use in memory and then event sourcing replay on that. But after the matching engine, we also send the data via Red Panda topics, and then those Red Panda topics are saved inside. It's on an append-only directory, and then every single microservice that subscribes to that specific topic in the same consumer group could listen to that. So that's very powerful, because you could create these in the same consumer group using the subscribe method. You could subscribe to these messages, and it's really cool where you could see each microservice, not just microservice, but each pod inside the deployment of each microservice. It reads like one message, processes, save to SingleStore, SingleStore like gets a really clean read, and then the second pod reads from the topic and then writes to SingleStore. So we have like 7 of those, and then it really helps our throughput by combining Red Panda and SingleStore. It's just really nice.
Yeah, that's fantastic. It's a great combination of technologies there.
Okay.
Let's take a few questions from the audience. Diogo.
Yeah, sure. Here's one question for you, Dandy. Do you expect to expand to the United States at any point?
To be in the United States, as in offer our service to the United States? Service. The answer to that question is yes. We'd love to offer our crypto platform service in the United States. We are currently not allowed to because of regulations. We'd love to because I mean I did my higher education there. Then it's always really cool to see what we built is used by our friends and also most U.S. persons in the United States. But to get there, we need to make sure we're regulated first in 50 states, and that would take a while, hopefully. So fingers crossed, we launch well and then we get there. Thank you for that question.
Awesome. Here's another question for you, Danny. Tell us a little bit about how data flows across your system. You are using a Kafka API compatible technology for that. Is that right?
Yes. So it's called Red Panda. The Kafka compatible API, it's really fast. The Vectorize team created it, and then we wrote a blog in it on that specific aspect, and we got a boost performance round trip time. So exchanges are I guess not compared to each other, but like their performance are based on what's called round trip time. So round trip time is when you send an order to the gateways, how fast could you get from sending orders to gateways to getting a confirmation back? So it's like you from point like entering the door of the exchange and going out from the door again. So that we got, so we're third back then before the matching engine v2 design. We were third in compared to any other exchanges, mostly OKX and Binance. We're third, but that itself we did a comparison between us before using Red Panda and post using Red Panda, and there was just by changing the application to Red Panda from Kafka, it yielded like 43% of performance upgrades, round trip time, right? So just by changing a host name. So if anyone in the trading community, they should probably try Red Panda too. It's really fast.
I want to thank you, Danny and Dominic, for the presentation. As a reminder, you'll receive an email with the recording and a follow-up so you can start a full workload today. We are offering each user $500 in credit. And lastly, please check out our other virtual events at singlestore.com/events. Thank you. Have a great rest of the day.
Thanks, everyone.
Thank you.